All right, so odds are at this point, not only I, but you have made mistakes. And you've written buggy code. A bug in a code is just a mistake, a logical error or otherwise, where the code just does not behave correctly as you intend. And up until now, odds are your debugging techniques have been to maybe look back at what I did in class, maybe ask a question online or in person. But ultimately, it'd be nice if you had some tools of your own with which to debug code. And this, honestly, is a lifelong skill. You're not going to emerge from CS50, and even 20 years from now, you're not going to be writing, if you're writing code at all, correct code all of the time. Like all of us on the staff continue to write bugs. Hopefully, they get a little more sophisticated and not sort of like, oops, I missed a semicolon. But even those kinds of mistakes we make too. But there's tools out there and techniques that can make your life easier when it comes to solving. Tell is that the first document Mark II computer from 1947, whereby if you read the notes here, and if I zoom in, this was an actual moth discovered inside of this big mainframe computer that was causing some kind of problems. And the engineers at the time actually thought it was funny that, wow, physical bug actually explains the issue. And it's been forever taped to this sheet of paper, which I believe now is on display in the Smithsonian. With that said, this is just representative of a logical bug. And that story is actually that story was often retold by a famous mathematician, then computer scientist, really, Dr. Grace Hopper, who actually worked not only on the Harvard Mark II computer, but its predecessor, the Harvard Mark I. And if you ever spent time yet in the engineering building across the river here, you can actually see much of this computer, which is along the wall when you first walk into the science and engineering complex. And indeed, as you've probably heard growing up, this is a mainframe computer. Like this is what Macs and PCs, so to speak, looked like back in the day, with very physical things that essentially implemented the zeros and ones that you and I take for granted now being miniaturized in our laptops and phones. So there's a piece of history there. If you visit campus, that side of campus sometime, do take a look. But let's consider then how we solve not, of course, physical bugs, but logical bugs. And let's consider something like this from last week, whereby we were trying very simply to print like this column of 3 bricks using hashtags of sorts. So let me go over here in just a moment to VS Code. And I'm going to go ahead and open a program I wrote in advance. And I'm bringing it to class because there's a bug in it. And I'd like to figure out how to solve this bug. So let me open up buggy0.c, which is version 0 of my code. And let's just take a quick peek at what's here. It's pretty short. It includes only standard io.h. It uses printf. It uses a for loop. And the goal, quite simply, is to print out that column of 3 bricks. Now, it's short enough that some of you, if you're getting comfy already with C, you might already see the logical bug. It's not a syntax error, like it will compile and run. But there's a bug there. And suppose that I'm very new to C. I'm very uncomfortable with C. It's 2 a.m. and I just can't see the bug. What are my recourses here for actually finding a mistake like this? Well, first, let's look at the symptom. Let me go down to my terminal window. I'm going to use make buggy0. Because again, the file is called buggy0.c. I'm not going to use clang. In fact, I'm never really going to use clang manually here and out. I'm just going to use make because it makes our lives easier. It does compile, no errors, so it's not syntax. It's not something silly like a missing semicolon. But when I run /buggy0, I of course see 1, 2, 3, 4. And this, of course, does not match the 1, 2, 3 bricks that I actually intended for that column. And yet, I'm starting counting at 0 as I usually do. I've got 3. I'm going up to 3. So where is my logical error? If it hasn't obviously jumped out at you already, well, how can I solve this? Well, first and foremost, perhaps the best technique for solving bugs, at least early on, is just use printf. Like thus far, we've used printf to say hello and other things on the screen. But printf is just a function for printing anything. And there's no reason you can't temporarily use printf to like print out the contents of variables, what's going on inside of your program, just to figure out where your mistake is. And then you can delete that line of code later. It doesn't have to stay there forever. So let me do this. Instead of just printing out in VS Code the hash symbol, let me do a little safety check here and print out the value of I. So let me go ahead and say something like I is. Now, I want to say I is this. But of course, this is not how I print out the value of I. If I want to print out the value of I, what should I put here? So %i for integer instead of %s for string. So there's still placeholders, but we use %s for integers. And now if I want to print out I just need the comma as the second argument and then I. All right, let me go ahead and back to my terminal window. Let me recompile the program because I've changed it. That still works fine. /buggy0. And now, let me increase the size of my terminal window here. You just see some diagnostic information, if you will. Like, this is not the goal. This is not what you should be submitting for this homework problem we're at 1. But it is helping us diagnostically know that, OK, when I is 0, here's a hash. When I is 1, here's a hash. When I is 2, here's a hash. When I is 3, here's a hash. Well, wait a minute. That's 1, 2, 3, 4. So clearly, I'm printing it one too many times. So let me look back at the code here by shrinking my terminal window. And let me just ask the group, where is, in fact, the mistake? Or what equivalently would be the solution? Yeah, in the middle. Yeah, instead of less than or equal to, use just less than. So you got to kind of pick a lane here. Like, if you're going to start counting from 0, you generally use less than and go up to, but not through the value. Or if you prefer, like in the human world, counting from 1 on up, you can use less than or equal to, but you have to be consistent. And in general, as a programmer, just always start counting from 0 if you're doing something canonical like this. But the solution is indeed just to change this by changing the less than or equal to less than. If I compile this program with make buggy 0 and then do .buggy 0 again, and let me increase the size of my terminal window, now you see, OK, almost the same output, but indeed I starts at 0 and goes up 2, but not through 3. All right, so printf, in short, can be your first diagnostic tool. Instead of just staring at the screen or raising your hand, use printf to see literally what's going on inside of your program by just printing out things of interest. And then once you've solved the problem, you can go back into your code, as I'll do here, by shrinking my terminal window. I'll delete the printf line, and now I'm ready to share this program with the world or submit it as homework or the like. It's just meant there to be temporary. Any questions on printf as a debugging tool? No? All right. Well, that only gets us so far. And honestly, as your programs grow and grow and grow, it's going to actually get really annoying to start going in and adding printfs, then removing them and figuring out if you've got multiple printfs, well, which one printed what. Like, it just gets messy eventually to rely on printf alone. So being a computer scientists have written software to make it easier to debug code. That software is what we would generally call a debugger, which would be the second tool of the trade that you can use to actually solve problems in your code. Now, in the world of VS Code, there's actually a debugger built in. So the graphical user interface you're about to see in VS Code isn't specific to CS50. It actually comes with VS Code, and it supports C and C++ and Java and Python and lots of other languages too. But it's admittedly a little complicated to just start using the debugger. You have to create a configuration file and do some annoying steps that just get in the way of solving real problems. So we have automated the process for you of just starting the debugger. And thereafter, it's sort of industry standard how you use it, but we save you the headache of having to create those configuration files. So suppose I want to do this. Suppose I want to try to debug this program step by step using special software. Well, how can I do that? Well, let me propose that if I revert this back to the original version, where I was less than or equal to 3, I'm pretty sure that I was printing too many hashes. So I'm going to do this. And you might have done this accidentally or never at all. But notice if you hover over the gutter, so to speak, in VS Code, the part of it all the way to the left of the editor, you see this sort of grayed out red dot. If you click there, it becomes a brighter red dot. And this represents what we're going to call a breakpoint. And this is just a visual indicator that you've put a stop sign equivalent there. And you're telling the debugger in a moment, stop running my code there. Why? Because I prefer to step through my code at sort of a human speed and not as computer speed, where it runs all at once. So I've set my breakpoint, which is step 1. And then step 2 is quite simply this. Instead of running the program itself, run a command called debug50, and then /buggy0. And now this will start your program, but inside of the debugger, which is a special program that smart people wrote that will empower you to now step through your code line by line at your own comfort pace. I'm going to hit enter. Some stuff's going to happen on the screen. Whoops. Notice this is a common mistake that I made accidentally here. Looks like I've changed my code. I did, because I went in and changed the less than or equal to sign. So let me go ahead and rerun make buggy 0, enter. Good. Now let me rerun debug50, enter. And now some stuff just happened on the screen. And it takes a moment to get started. But once it's started, you'll see this. You'll still see your code, but you'll see this yellow highlight, which you've probably not seen before. And notice that it's specifically highlighting the same line that I set a breakpoint on. Why? That just means the program has the debugger has executed all of these lines except for line 7. It has broken, not in a bad way, but it has paused execution on line 7, so it hasn't yet printed any hashes. And you can see that. No hashes in the terminal window yet. It's paused execution. But what's interesting with the debugger is the stuff over here on the left-hand side. In the debugger here, you'll see under variables all of your so-called local variables. And we haven't really made a distinction between local and something called global. But for now, local variables just means all of the variables that exist in your function. So I currently has a value of 0. OK, and that makes sense. So now how do I step through my code and see what it's doing? Well, at the top of the screen here, you'll see some playback icons, kind of like a video player, but they have special meaning. This first one will just play the rest of your program all the way to the end. So you only click that if you sort of solved a problem and you just want to run it to completion like before. But the next 3, or next 2 really, are really the juiciest. The second one here, if you hover over it eventually, you'll see that it's called step over. Step over means that the debugger will run this currently highlighted line of code, but it's not going to dive into it. So if it's a function like printf, it's not going to start stepping through printf line by line. Why? Because I can pretty much assume printf written decades ago is correct. Problem's probably with me. But this next line, if I did really want to step into the printf code to figure out how it works or find some problem in it all these years later, you can step into printf, and then the screen would change, and you'd see each of the lines for printf line by line, at least if you have the source code for printf installed. All right, I'm going to use the first one, step over, and watch as the yellow highlight moves, and watch as in the terminal window there's a hash symbol. Here we go. There's one hash. Now notice line 5 is highlighted. That means it has paused on line 5. Line 5 has not yet been executed. So what does that mean? The value of I, per the top left-hand corner, is still 0. But as soon as I click step over again, watch what happens at the top left, where I is a variable on the screen. Now I, and it flashed briefly, has a value of 1. And now if I step over again, watch the terminal window. There's my second hash. Now let me click step over on the for loop. Watch the variable at top left. Now 1 goes to 2. Now let me click it again. Third hash. And here's where the logical error is perhaps revealed. Let me go ahead and step over the loop. Now I is 3. Wait a minute. I'm still going to print out a hash. Well, there it is. There's the 4th hash. And at this point, hopefully the light bulb proverbially has gone off. I realize, oh, I screwed up. I can either stop the program altogether with the red square, or I can just let it run all the way to the end, which just terminates everything. At this point, I just want to get back into my code and start fixing things. And you can close, for instance, as I will here, the File Explorer just to hide the panel that opened. So that's debug 50, but it's not a CS50 thing. That just starts the debugger for you, which is something you'd find in most any programming environment nowadays. Questions on debugging? Questions? Yeah? Good question. Where does it tell you where it went wrong? So sadly, it does not tell you any of that. The onus is still on you, the human, to use this tool productively to walk through your code at a saner pace. But your brain is the one that still needs to solve it. And I don't doubt down the line, with artificial intelligence and more, programs like this will get all the more helpful and start answering questions like that for us. And there are other tools we'll introduce you this semester that are even more powerful than this. But for now, it's just a tool really to slow things down and not have to change your code. The fact that I had that panel on the left that just showed me I's changing value is just an alternative to printf. And I can step through it a little more slowly. Other questions on debugging? No? Let me show you one final example with this debugger here. And this one, too, I wrote in advance. Let me close buggy0.c. And let me open up buggy1.c, my second version thereof. Let me close my terminal window for a second and give you a quick tour of this program, which similarly has a mistake. Now, at the top of this program, some familiar includes CS50.h and standard.io.h. This is not something we've seen before. It's specific to this example, a function called getNegativeInt. Takes no arguments, and it returns an integer. What does it do? It literally gets a negative integer, ideally from the user. Fun fact, though, it doesn't correctly. That's the bug. GetNegativeInt is broken at the moment. So what does main do? Well, main just calls this function, passing in nothing in parentheses, no inputs, and it stores the return value in I. and then it just prints out I on the screen. So honestly, just by eyeballing this, I feel comfortable enough with programming in C. I think main is correct. Let me just stipulate main is correct. But there is going to be a bug down here. Now, what's the bug down here? Well, let me look at get negative ints implementation. Notice this first line, 12, is identical to the prototype up here. The prototype is sort of stupidly required up here because C reads things top to bottom, left to right. The compiler technically does. So if you reference get negative int here, but you don't implement it until down here, and you haven't told C in advance that it will exist, again, you get the error we saw last week. All right, so how does get negative int work? We declare a variable called n. We've got a do while loop that does what? It uses getInt, which comes with the CS50 library per last week. It prompts the user for negative integer, quote unquote, and stores the value in n. I then do all of this while n is less than 0. Right? Remember we used a do while loop last week to make sure the human cooperates and doesn't give us the wrong type of value, be it positive or negative or something else. And then we return n. And there's some subtleties. Anyone recall or have an intuition for why I've declared n on line 14 instead of on line 17? This is a C-specific thing. Exactly. There's this notion of scope in C, and we'll continue to see this over time, whereby a variable only exists inside of the most recent curly braces that you've opened. So if I've declared n here on line 14, I can use it anywhere between lines 13 and 21, because those are the nearest curly braces. If by contrast, as you note, if I instead said this, int n equals getInt and so forth, and didn't have the current line 14, well, n would exist inside of these curly braces, but not here, which is too late, and definitely not here. So you just have to declare it first and then use and reuse it as such. Now, let me just show you how I can debug this, but let me show you the symptoms first. Let me open my terminal window. Let me run make buggy1. Compiles OK, so it's not something silly like a semicolon, /buggy1, and I'm asked for a negative integer. All right, let me give it -1. Enter. Well, the main function is supposed to print out what I typed, but it clearly didn't. It's prompting me again. All right, so maybe it'll like -2. No, maybe -3. 50? OK, so it's definitely broken, right? It kind of seems logically to be doing the opposite. Now, you can perhaps see why this is happening already. These are deliberately simple programs for demonstration's sake. But let's do this. Let me go ahead and set a breakpoint in main, even though I'm pretty sure main is correct. But it just helps me start my thought process. Start with main and then take it from there. Let me run now debug50 /buggy1, enter. And let's see. With that breakpoint now, the GUI is going to reconfigure itself. It's going to pause on line 8, because that's the first interesting line inside of main. So I could have just put the breakpoint on line 8 too. It's smart enough to know that if I set it on 6, you really mean line 8, because that's the first actual line of code. And watch now what happens. If I step over this line, notice that I, which at the moment seems to have a default value of 0, more on that another time. But if I click step over, like before, I'm prompted for a negative integer. Let me type -1, enter. And now notice there's no additional yellow highlight. Why? Where am I currently stuck logically? Yeah, just logically, I must be in that do while loop. And even if you don't understand it, like that's the only explanation. If you keep getting prompted, surely there's a loop going on. There's only one loop in my code, so there's probably a problem there. So OK, I can't just set a breakpoint in main and then wait for this to work. So let me just let me stop this with the red square. And let me think, all right, instead of, I can still set my breakpoint in main, but let me rerun the debugger instead. And this time, not step over that line of code. Let me step into that line of code. So watch what happens now. Instead of clicking the second icon here, let me click the third, whose name is indeed step into. And watch as the yellow highlight does not move to line 9. It dives into line 8. The function on line 8, thereby bringing me whoosh down to line 17. It's kind of going down into that next function. Now, it didn't bother pausing on line 12 or 13 or 14, because there's nothing intellectually interesting there happening yet. The juicy part really starts, it would seem, in line 17. So now notice, n is my variable at the top left. If I click, I don't want to click step into now, though. What would go wrong if I click on step into? Or what would it do that I don't think I want to do? Yeah. Yeah, it would step into getInt, but I'd like to think that the staff's version of getInt is correct, and that's not our problem today. So I want to step over it. And watch now at top left that nothing happens yet to the value of n until I go to the terminal window now and type in something like -1. Now notice it jumps to line 19, which is the next interesting line. Top left, n indeed is -1. And here's where I can now pause as a human and think, all right, so while n is less than 0. All right, n per the top left corner is -1. So all right, while -1 is less than 0, well, obviously that's true mathematically. So what's going to happen? It's a do-while loop. So when I click on step over again, it's going to go to this line because it's at the end of the inside of that loop. And now here, it's looping through again and again. All right, let me do this once more. I'm going to step over. All right, I'm going to type in -2, and it's the exact same thing. Now is my chance on the yellow line. OK, wait a minute. -2 is obviously less than 0. Let me try this one more time. Click it once here. And now, all right, let me give it 50. And now, OK, while 50 is less than 0, that's not true. So the loop is over, because it's not going to do it while 50 is less than 0. That's not true. So now watch, when I click step over once more, it then finishes the loop. Even though there's nothing more to do, it's now about to return n. It jumps back up to main, where I left off on line 9. It now prints in my terminal window the number 50. And hopefully at this point, to your question earlier, my human brain has realized, oh, I'm an idiot. Like, I flipped my sign there. So I probably, let me stop this. I probably want to do something like this. If the goal is to get a negative integer, I probably want to say, while n is, for instance, greater than or equal to 0 would work. So while n is greater than or equal to 0, keep doing this. And that's the logic I wanted to express. So the debugger just saves me from staring at the screen, raising a hand, sort of asking someone else. At least in this case, it allows me to go through it at a healthier pace. Questions now on debug 50, which should be your new friend, even if it's not your first instinct after printf. Any questions on debug 50? No? All right. Well, there's one last technique we can equip you with here. And that is, in addition to printf and a debugger, no joke, a rubber duck is actually a reasonably recommended solution to finding bugs in your code. To your question earlier, the duck 2 is not going to solve the problem for you. But if you've wondered why this little guy has been here for so long, there's this technique. It has its own Wikipedia article called rubber duck debugging. The idea of which is that if you're home in your dorm room wrestling with some bug in your code, printf didn't quite reveal the source to you, debugger isn't really helping, honestly, maybe it would help to just sound out what problem you're having. Similar to going to office hours, talking to a TA or a professor, just walking through your problems, because in sort of talking to the duck about, the fact that you're doing this while n is less than 0, and then if it is, oh, wait a minute, I'm an idiot. Not just for talking to the rubber duck, you realize hopefully in expressing yourself literally verbally, you probably will hear with non-zero probability like some illogic in your statement. And just by sounding things out, you'll realize like, oh, that's my problem. And so, frankly, if you have roommates, you can also use a roommate for this. But the rubber duck is just sort of a go-to when your roommates have no interest in your, C problem set, talking something through that as such. And this is an invaluable technique. I admittedly tend not to do it so much with a rubber duck, but ideally with colleagues, human colleagues. But just talking through things often will help you just realize, oh, I said something illogical. Now I can go back to the code. So don't solve problems by staring at your screen endlessly for minutes, for hours. At that point, it's time for a break, time to walk away, time to talk to the duck if you've already exhausted some of those other tools. As an aside, on your way out today at the end of class, we have clearly plenty of rubber ducks for you. It's become a thing over the years, at least among some, to bring the duck with them when they travel and send us photos. Here, for instance, is CS50's rubber duck debugger, aka DDB for duck debugger, which is a pun on a geekier program called GDB, the GNU debugger, which is an actual piece of software for debugging. This is CS50's debugger in the hills of Puerto Rico, also here on the sea. He made its way to San Francisco here. Also down by Fisherman's Wharf by the sea lions, if familiar. Here at Stanford, where there's a William Gates Computer Science building for computer science. Down the road in SF at Google. And this is the Trevi Fountain in Rome. And lastly, the Colosseum. So we'll be curious to see in the coming years where your Duck 2 travels. So that then was quite a bit. Why don't we go ahead here and take a short 5-minute break. No snacks yet. You're welcome to get up or sit down. But we'll also, over these 5 minutes, play a fun video related to rubber ducks. So we'll return in about 5.